Welcome. Tonight there is nowhere you need to be, and nothing you must solve. Let your shoulders soften, let your breath find its own slow rhythm, and let the room grow dim and kind around you. Tonight we wander into the smallest world there is, the quantum world, humming beneath everything you can see. This is the Circadian Institute, where each night we travel somewhere vast or strange or wonderfully small, and let the slow rhythms of nature carry a tired mind towards sleep. Tonight our subject is the quantum world, the secret life of light and atoms. If this voice helps you rest, subscribing keeps these long, calm nights within reach. There is nothing to memorize tonight and no test in the morning. The quantum world is famously strange, but strangeness told slowly becomes a kind of wonder, and wonder is a fine doorway into sleep. You only have to listen and let the smallest things in the universe keep you gentle company. We will move without hurry tonight, from the warm light of a candle to the inside of the atom, through clouds of possibility and threads of entangled light, down into the coldest places ever made, and back to the quiet quantum glow of a night sky. Nothing to hold on to, only small, slow wonders. Begin with something old and familiar, a small flame in a dark room. For most of history, light was simply light. It warmed, it glowed, it went out. Nobody guessed that inside that soft yellow flicker hid a puzzle deep enough to change all of physics. Watch any fire, and you see the clue. As embers cool, their light slides from white to orange to a deep, tired red, and then to darkness. The color of the glow follows the heat faithfully, every single time in a candle, in a hearth, in the molten heart of a volcano. At the end of the 1800s, physicists tried to write down exactly why hot things glow with those colors, and their best equations failed strangely and badly. Something about light itself was missing from the picture, something nobody had imagined yet. In the year 1900, a careful German physicist named Max Planck found the missing piece. The numbers only worked if light could not flow smoothly, like water, but came instead in tiny separate packets, little grains of light, each carrying a fixed amount of energy. Planck called them quanta, and he hardly believed in them himself. He thought they were a clever trick of arithmetic, but the trick refused to go away. Those little grains were real, and the whole strange world we visit tonight is named after them. Let that first small light glow on as you settle. 5 years later, a young patent clerk in Switzerland took Planck's reluctant trick and dared to treat it as the truth. His name was Albert Einstein, and in 1905 he proposed that light truly is made of particles, discrete flying grains of energy we now call photons. He was explaining a small mystery called the photoelectric effect. Shine light on a metal plate, and under the right conditions electrons pop free from the surface, but only the color of the light mattered, not its brightness. Dim blue light could do what blinding red light never could. Einstein saw why. Each electron is freed by a single photon, one grain of light striking one particle of matter. A blue photon carries more energy than a red one, so color decides everything. Light arrives not as a smooth wave of brightness, but as a soft rain of countless tiny impacts. "It sounds simple now," said slowly in the dark. It was not. The idea was so bold that physicists resisted it for years, yet every experiment agreed. When Einstein received the Nobel Prize, it was for this, the grains of light, and not for his famous theory of relativity. So the first lesson of the quantum realm is already here, and it is gentle light. The softest thing you know is a shower of tiny gifts, countless small packets of energy, falling on your closed eyelids even now from every lamp and star. Rest under that quiet rain. But here the story folds in on itself beautifully. 100 years before Einstein, in 1801, an Englishman named Thomas Young had proven carefully convincingly the exact opposite, that light is a wave rippling through space the way rings ripple across a pond. Young let light pass through two narrow slits side by side, and on the wall beyond he saw not two bright stripes, but many, a long ladder of light and shadow. Only waves do that. Where two ripples meet crest to crest they brighten, where crest meets trough they softly cancel to darkness. You have seen this wave nature of light yourself many times. It paints the shifting rainbow colors on a soap bubble, the glassy bands on a film of oil after rain, the soft shimmer inside an opal, light waves folding over themselves, making color out of interference. So which is it? Young proved light is a wave. Einstein proved light is a particle. And the deeply strange, deeply true answer of the quantum world is both. Light travels like a wave and arrives like a particle, and it will show you whichever face your experiment asks to see. Nothing in daily life prepares you for that, and nothing needs to. You are lying still. You can let it be true without forcing it to make sense. Wave and grain, ripple and rain, light is comfortable being both, and tonight, so are you, half awake, half adrift, and entirely at ease. The two-slit experiment grew stranger and lovelier with time. Physicists learned to send light through the two openings, one photon at a time, single grains of light, each crossing the apparatus alone, each landing on the far screen as a single small dot. One dot tells you nothing, but let the dots gather, night after night, thousands upon thousands, and the old ladder of bright and dark stripes slowly assembles itself, the signature of a wave, painted dot by particles traveling alone. Think about what that means slowly. Each photon went through alone, with nothing to interfere with except somehow itself. As a wave of possibility, it passed through both doors at once, folded over its own ripples, and then arrived as one modest dot in a place those ripples allow. And if you place a detector at the doors to catch which one the photon truly used, the stripes vanish, watched. Light behaves like a particle and takes one door. Unwatched, it takes both. The quantum world keeps its possibilities open until the last possible moment. There is something restful in that, oddly. The universe itself declines to decide until it must. Nothing tonight needs deciding either. Let your own possibilities stay soft and open, both doors ajar as you breathe slowly down toward sleep. Before we go deeper, let us feel the scale of the country we are entering. An atom is so small that a single drop of water holds more of them than there are stars in the observable universe, more worlds in a bead of rain than all the suns of all the galaxies. If you enlarged an apple until it was the size of the Earth, its atoms would be roughly the size of the original apple. That is the doorstep of the quantum world, a realm so far beneath your fingertips that no microscope of glass and light can ever quite see into it. And yet that hidden country is not far away. It is not beyond the stars or under the sea. It is here in the cotton of your blanket, the water in the glass beside you, the iron in your blood. You are made of the quantum world, every soft breathing inch of you. Down there, the rules are different. Things blur and hum. Particles borrow energy and give it back, slip through walls, spread out like mist, and snap into focus only when asked. It sounds restless, but it is a steady, lawful restlessness, the same quiet hum since the beginning of time. All night, beneath your stillness, that hum goes on, atoms swaying, electrons humming in their clouds, photons hopping from your lamp to your wall. The deepest layer of the world never sleeps, which is precisely why you can. Something steadfast is always minding the foundation. Let us pause here at the doorway of the tiny world and breathe. There is no hurry on the far side of that door. The quantum world has been humming for nearly 14 billion years, and it will hum just the same whether you follow every word tonight or none at all. Feel how the day loosens its grip. Whatever was sharp this afternoon is going soft at the edges now, the way a bright point of light goes soft when your eyes relax. Let it blur. Precision is for the morning. The night prefers things gentle and approximate. Let your breath become slow ripples on a pond, out, and the rings widen in, and the water gathers out again, and the rings widen further, wave after wave, each one a little longer, each one a little lower, carrying you down toward stillness. Soon enough, we will step inside the atom itself, and find it stranger and emptier and more beautiful than anyone guessed. But there is no rush at all. Stay here by the doorway as long as you like, breathing in rings, sinking softly toward sleep. Step inside an atom, and the first surprise is the silence of all that space. An atom is almost entirely empty. Its nucleus, the dense little heart holding nearly all the mass, is tens of thousands of times smaller than the atom around it. If an atom were a great cathedral, its nucleus would be a single grain of sand resting at the center of the floor, and the electrons would be faint motes of dust somewhere up among the rafters. Everything between, which is nearly everything, is emptiness. And since you are made of atoms, you are made mostly of that same emptiness. If all the truly solid matter in every human being on earth were pressed together, nucleus to nucleus, it would fit inside a single sugar cube, a strange and humbling little thought. Yet the emptiness is not nothing. It is woven through with fields, electric and quantum fields that fill the hollow of the atom, the way music fills the hollow of a hall. What feels solid when you press this pillow is not stuff meeting stuff, it is field meeting field, firmly and politely declining to overlap. So tonight, you rest on emptiness that holds, supported by invisible fields that have never once failed. The mattress beneath you is a cathedral of quiet space, and it bears you up all night without effort, the way it has borne everything always. There was a real problem with the atom a century ago. An electron circling a nucleus is a moving charge, and by the old physics, a moving charge must constantly radiate light, lose energy, and spiral inward. Every atom in the universe should collapse in a flash in less than a blink. But atoms do not collapse. They are the steadiest things there are. Most have lasted unchanged since the early universe. The chairs and walls and trees stand firm. So the old physics had to be wrong about the small world, and in 1913, Niels Bohr saw how. Bohr proposed that electrons may only occupy certain fixed rungs of energy, like steps on a staircase with no standing between the steps. An electron on the lowest rung simply has nowhere further to fall. The bottom step is the bottom step, and there it rests forever if need be. That is why matter is stable, why the world does not slowly wink out. The quantum rules forbid the final fall. Every atom in your body sits on staircases like that, electrons resting on their lowest comfortable steps, holding the shape of you with no effort at all. Let that settle in as you settle down. The deepest law of the small world is not chaos, but rest, a ground floor, a lowest step, a state of least energy where things can stay without striving. Physicists call it the ground state. You're headed there yourself tonight. When an electron does move between its steps, it moves like nothing else in nature. It does not glide or climb. It is on one step and then it is on another with no journey in between, the famous quantum leap, which is not a great jump at all, but the smallest event in the world. Falling to a lower step, the electron releases its extra energy as a single photon, one grain of light, with a color set exactly by the height of the fall. Climbing, it must swallow a photon of precisely the right color, no more and no less. The staircase writes the colors. And because every element has its own staircase, every element sings its own colors. Neon glows that famous red-orange. Sodium street lamps pour out their old amber. Heated copper breathes green into a flame. Each is an atomic signature written in light. This is how we read the universe. Point a telescope at a star 1,000 light years away, spread its light into colors, and the missing and shining lines tell you exactly which atoms burn there: hydrogen, helium, iron, their staircases glowing across the void. So when you see neon humming over a late-night diner, or the amber of an old street lamp through the curtains, you are watching quantum leaps, billions of tiny falls, each one releasing one small grain of color. The night is lit by electrons coming home to rest. Here is a quiet marvel we rarely pause on. Every atom of a kind is perfectly identical. Every hydrogen atom in the universe has exactly the same staircase, the same size, the same colors. Not similar, identical to the last decimal nature keeps. Nothing built in the large world manages that. No two leaves, no two grains of sand, no two handmade bells ring quite alike. But the quantum rules are not suggestions. They are the same everywhere, and so their atoms come out the same, in your body, in the sea, in a galaxy 10 billion light years away. An atom of iron in your blood is indistinguishable from an atom of iron in a star. Not roughly the same, but utterly the same. Swap them and the universe would not notice. There is no worn iron, no young hydrogen, no foreign oxygen. Atoms do not age and do not differ. That sameness is why the universe holds together as one place. Light from the farthest galaxies carries the familiar colors of hydrogen, and we recognize it instantly, like handwriting we know. The laws here are the laws everywhere. Nothing out there is truly strange to us. And it means something tender, too. The atoms lent to you for this lifetime are flawless. However tired the day has left you, your smallest parts are perfect, ageless, and exactly as they should be, and they will keep their perfect time all night while you rest. Let us rest a moment in the house of atoms. It is a good house, mostly quiet space, held up by fields that never tire, furnished with staircases of light, every brick of it identical and ageless. You have lived in it all your life without once having to think about it. Feel the bed holding you, field meeting field, steady as it has been since the first atoms formed. Nothing about that support requires your attention. It worked before you knew the word electron, and it works exactly as well with your eyes closed. Let your thoughts step down their own staircase now, each breath one step lower, each step a little dimmer, a little warmer. There is no standing between the steps and no need to climb back up. The lowest step is rest, and rest is allowed. In a little while, we will meet the famous fuzziness of the quantum world, the clouds and the uncertainty, and find that even the fuzziness is calm when told slowly. But stay here on the low warm steps as long as you like, going down one breath at a time. We have been speaking of electrons as little planets on staircases, and that picture served Bohr well for a while. But the truth worked out in the 1920s is softer and stranger. An electron in an atom is not at any one place at all. It is spread out, like a small cloud of maybe. In 1926, Erwin Schrödinger wrote the equation that rules this cloud, a wave equation, smooth and flowing, describing not where the electron is, but where it might be found, and how strongly it leans toward each possibility. The cloud is thickest where the electron is most likely to appear and thins away to nothing far from the nucleus. Ask where the electron is, and the atom answers with weather, 90% chance here, a soft drizzle of likelihood out there, until you look that weather is all there is. When you do look, when anything measures the electron, the cloud gathers itself in an instant and answers with a single point here. Then, left alone, it breathes out again into mist. Matter at its root is not grit but tendency, not stuff, but a leaning toward. And the cloud shapes are beautiful. Some are round as full moons, some lobed like petals, some layered like roses, the hidden geometry that decides all of chemistry. You are built at the bottom from a garden of probability flowers blooming steadily in the dark of every atom. In 1927, a young Werner Heisenberg found a rule hiding at the very bottom of nature. You may know a particle's position, or you may know its motion, but the more precisely you pin down one, the more the other slips through your fingers. Never both, never fully. This is not clumsiness, and no finer instrument will ever cure it. It is woven into what particles are, waves folded into packets. A wave squeezed into a sharp position has no clean rhythm. A wave with perfect rhythm stretches everywhere. The trade is absolute. Uncertainty is why the electron clouds exist at all, and why atoms have their size. Squeeze an electron toward the nucleus and its motion grows wild, pushing back outward. The atom settles where the squeezing and the wildness balance, a truce drawn by Heisenberg's rule. It even means nothing can ever be perfectly still. Perfect stillness would mean knowing both position and motion exactly, position fixed, motion zero, and that is forbidden. So even at the coldest cold, Every atom keeps a faint tremble, a whisper of motion called zero-point energy. There is a kindness in this law if you listen for it. The universe itself is not required to be exact, and neither are you. Tonight your thoughts may stay unfocused, your plans approximate, your edges soft, blur is lawful, blur is how nature rests. No night about the quantum realm is complete without a certain cat. In 1935, Schrödinger told a story, only a story, no cat was ever harmed, to show how strange his own theory sounded when carried up into the large world. Seal a cat in a box, he said, with a device triggered by a single quantum event, one atom that may or may not decay until the box is opened. The atom state is genuinely undecided, a blend of both possibilities. So is the device, and so absurdly is the cat awake and asleep at once. Schrödinger meant it as a protest. Surely nature could not work like that for anything as large and warm as a cat. And in practice it does not. Large warm things are never left alone enough to stay undecided, as we will see before morning. The blur belongs to the small. But for atoms, the story is simply true. A single atom really can hold two possibilities at once, decayed and not, here and there, this rung and that, until the world asks. Physicists call the blend a superposition, and they work with it daily, as calmly as a baker works with flour. Let the famous cat retire now to what cats do best. Somewhere in the story it was always also asleep, and that is the half of the superposition you may keep. Curl up on your cushion of possibilities, and let the box of the day stay gently closed until morning. So the small world keeps its options open. Clouds of maybe, blends of both. Then what makes anything definite? The honest, plain answer: interaction. When a quantum thing touches the wider world, a detector, a mote of dust, a single photon of light, it must answer, and it does. The answer is random, genuinely random, not merely unknown. The cloud gives its probabilities. The dice are thrown once, and one possibility becomes fact. Einstein never liked this. God does not play dice, he said, yet every test ever run says the dice are real and they are fair. Fair is the right word. No single quantum event can be predicted, but their averages are the most reliable numbers in all of science. Out of pure chance, perfect steadiness, the glow of a lamp, the tick of a clock, the chemistry of your calm breathing, all built on honest dice. Think of rain on a roof. No one can say where the next drop will strike, yet the steady hush of the whole is as dependable as anything you know. The quantum world is that hush, billions of unpredictable little answers blending into the smooth, trustworthy sound of reality. You need not decide tonight whether chance or law feels more comforting. In the quantum world, they are the same thing wearing two coats. Let the dice fall where they may in the small world. Up here, the hush they make together sounds exactly like rest. Let us rest inside the soft weather of the quantum world for a moment. The clouds of maybe, the gentle rain of chance, the lawful blur. Nothing here has hard edges, and for the next few minutes neither do you. Whatever the day demanded, precision, decisions, sharp answers, the night runs on different physics. Here, position may stay vague. Here, several possibilities may rest side by side without quarreling. Here, not even the universe insists on knowing everything at once. Let your breath be the only measurement, a slow, kind one, asking nothing in, and the cloud of you gathers a little out, and it spreads wider and thinner and calmer, settling over the evening like mist over a meadow. Whenever you wish, we will follow two particles that share one fate across any distance, the tender strangeness called entanglement. But there is no hurry at all. Stay here in the soft weather, spreading and settling, breath by breath. Sometimes two particles are born together, twin photons from a single flash, or a pair of electrons from one event. The quantum rules then do something with no everyday parallel. The two are described by a single shared cloud of possibility, however far apart they travel. Physicists call it entanglement. Each twin alone is undecided, a blur of both possible answers, but the blurs are linked. Ask one twin its state, and the answer of the other is settled in the same instant, perfectly matched even with a galaxy between them. It is less like two letters sealed in envelopes and more like one coin spinning in two places at once. Until it lands, neither side exists. When it lands everywhere. The pair is not two things in agreement, but one thing wearing two addresses. Einstein found this intolerable and gave it the most famous nickname in physics, spooky action at a distance. In 1935, he and two colleagues argued it proved the theory incomplete. Surely the answers were written secretly inside each particle all along. It was a fair and careful objection, and it slept in the footnotes of physics for 30 years until someone found a way to put the question to nature herself. That story, one of the loveliest in science, is where we go next. Breathe slow. The universe is about to answer. In 1964, an Irish physicist named John Bell did something quietly brilliant. He found that the two ideas, hidden answers written in advance or one shared undecided cloud, would leave slightly different fingerprints in the statistics of many measurements. The question became testable. Through the 1970s and 80s, experimenters took up the challenge, most famously Alain Aspect in Paris in 1982, sending twin photons down long, dark corridors of apparatus and questioning each pair before any signal could pass between them. The universe answered clearly and repeatedly, "There are no secret, pre-written answers. The twins truly are one undecided whole until asked." Einstein's hoped-for hidden script does not exist. Entanglement is exactly as deep and strange as the equation said. In 2022, the Nobel Prize went to Aspect, Clauser, and Zeilinger for those decades of careful asking. The strangest claim ever made about reality is now among its best-tested facts, verified across laboratories, across cities, even between the ground and satellites. And here is the soft footnote that lets you sleep. Entanglement carries no messages. The answers are random on each side. Only when the two notebooks are later compared does the perfect matching appear. The universe keeps its deepest connection and keeps it discreet. Entanglement long seemed like philosophy with no use, a curiosity for late-night seminars, no longer. It has become a working material, as real to engineers now as copper wire, and the quiet foundation of technologies being built while you sleep. One gift is unbreakable secrecy. Keys for coded messages can be woven from entangled photons, and the laws of physics themselves stand guard. Any eavesdropper who touches the photons disturbs their delicate state and is instantly revealed. not hard to crack, impossible. Another is the strange art called quantum teleportation. No matter is moved, but the complete quantum state of one particle is transferred onto a distant partner using an entangled pair as the bridge. The original blurs the faraway twin becomes its perfect continuation. And entangled particles are the working heart of quantum computers, machines that hold many possibilities at once and weave them together, exploring in one breath what ordinary computers must try one path at a time. We will visit those gleaming machines later tonight. For now, keep only the image. Beneath the ordinary world run threads of perfect correlation, quiet as held breath, linking small things across great distances. The universe is laced together more finely than it looks. You may rest inside that weave. Let us rest in the weave a moment. Twin photons over Paris, threads of light to satellites, notebooks that always agree. You do not need to hold any of it. The weave holds itself, and tonight, in its quiet way, it holds you too. There is something kind in a universe that is connected more deeply than it needs to be. Connections that carry no demands, no messages, no errands. Just correlation, pure and silent. Some bonds simply hold and ask nothing. Let your breathing entangle with the night's own rhythm, the slow swell of wind outside, the settling of the house, the soft tick of cooling walls. Two systems, one shared calm. No signal needs to pass between you. The matching happens by itself. Before long, we will watch particles walk through walls and discover that the sun itself shines only because they can. But the walls can wait. Stay woven into the stillness a while, matched and calm, sinking slowly towards sleep. Roll a ball at a hill too high for it, and it rolls back always, every time. That is the contract of the large world, but a quantum particle approaching a barrier it lacks the energy to climb does something softly impossible. Sometimes it is simply found on the other side. The cloud of possibility explains it. A particle's wave does not stop dead at a wall. It fades into it, thinning fast, and if the wall is thin enough, a whisper of the wave survives to the far side. A whisper of wave means a small but honest chance of being there. Physicists call it tunneling, though nothing is dug and nothing broken. The particle does not batter its way through or climb over. It is for a moment allowed to be where it could not afford to be, uncertainty lending it the toll, the debt repaid before nature checks the books. In 1928, George Gamow used tunneling to solve a standing riddle: how particles escape the iron grip of an atomic nucleus in radioactive decay. They do not break out. They lean against the wall of the nucleus, calmly improbable until one day they are outside. Tunneling is rare for any single try, but atoms try trillions of times each second, and so the impossible becomes routine. Remember this small magic, because without it, no star in the sky would shine, and that is where we drift next. The sun shines by fusing hydrogen into helium in its core. But there is a problem, and it is enormous. Two protons repel each other ferociously. To touch and fuse, they must overcome their electric repulsion, and even at 15 million degrees, almost none move fast enough. By the old physics, the sun is too cool to burn by a wide margin. the proton's walls of repulsion should turn nearly every approach away, and the great furnace should stand cold and dark. The fact that mornings exist is, strictly speaking, a quantum phenomenon. Tunneling saves the day and the day itself. The proton's waves overlap their walls of repulsion, and a precious few slip through and fuse, releasing warmth. The chance per meeting is fantastically small, but the sun's core holds so many protons meeting so often that it burns steadily. And the smallness of that chance is a blessing. Because fusion is so reluctant, the sun spends its fuel slowly, burning for 10 billion years instead of exploding in an afternoon. The same shyness that almost forbids the fire is what makes it last long enough for life. So, sunlight is tunnel light. Every warm afternoon you have ever known was paid for by particles doing the gently impossible deep in the heart of a star. The wall said no, the quantum world said sometimes, and sometimes repeated endlessly, is a sunrise. Here is a fact made for the middle of a sleepy night. The light warming your face on a summer day is, in a deep sense, ancient. A photon born in the sun's core does not fly straight out. It is absorbed and re-emitted, jostled and redirected a million times. Step by tiny step, the light performs a random walk through the crowded furnace, a few millimeters forward, sideways, back again, taking by most estimates many thousands of years to wander from the core to the bright surface. Patience is built into daylight. Then, suddenly free, it crosses the void to Earth in just over 8 minutes. The longest imprisonment, the swiftest release, the sunshine of one ordinary afternoon left its birthplace before the pyramids were dreamed of and finished its journey while your kettle boiled. Starlight tells the same story written longer. The light of the farthest stars you can see set out before there were cities, before there was writing, sometimes before there were people at all, and ends its travel tonight in somebody's quiet, upturned eye. So when light falls on you, something old and well-traveled is arriving home. Let tonight's darkness be the comfortable opposite. Nothing arriving, nothing demanded, just the long, soft pause between journeys. Even light rests in its way, inside the sun. Some atoms are restless at heart. Their nuclei hold a little too much energy, and one day, without warning or reason, they let it go. Radioactive decay is tunneling's other face. The moment of escape cannot be predicted, ever, for any single atom. Yet gather enough restless atoms and perfect order emerges. Half of any sample will have decayed after one fixed span, the half-life, as dependable as any pendulum, individually lawless. Together they keep some of the truest time in nature. We read those clocks everywhere. Carbon in old wood and bone ticks down across thousands of years, dating campfires and cathedral beams. Uranium ticks across billions, dating the Earth itself. The age of the world is written in quantum dice, thrown steadily since the beginning. There is even gentle use in their warmth. Deep space probes too far from the sun for solar panels are kept alive for decades by the steady glow of decaying atoms, little quantum hearths, warming instruments through the long dark between the planets. Unpredictable alone, faithful together, by now you know that is the quantum world's signature, repeated at every scale. Let it be your lullaby's rhythm too, any single breath unremarkable, the long, slow sum of them carrying you reliably into sleep. Let us rest here, warmed by what we have learned, that sunlight is tunnel light, that daylight is thousands of years old, that the impossible, repeated gently enough, often enough, becomes the most ordinary thing in the world. Morning itself is a quantum gift. Somewhere far above the night, the sun is still at it, protons leaning on their walls, the rare ones slipping through, the furnace breathing its 10 billion year breath. None of it needs your attention. The fire is banked, the night shift is covered. Let your own walls grow thin now, the ones between waking and sleeping. You do not need to climb over into sleep or force any gate. Lean against the boundary the way a particle leans, unhurried, and let the night do what thin walls allow. In time, we will listen to the quietest place there is, the vacuum itself, and find that even nothing in this universe hums with a soft something. But lean here first against the kind, thin wall of sleep as long as you like. In 1928, the English physicist Paul Dirac wrote an equation so beautiful it told him more than he had asked. It described the electron perfectly and then quietly insisted that a mirror twin must also exist, a particle just like the electron but with the opposite charge. He hardly dared believe it, but in 1932, the mirror electron was found in the rain of particles falling from the sky, the positron, the first piece of antimatter. Every kind of particle, it turned out, has its opposite, waiting in the wings of the equations. When a particle meets its antiparticle, the two vanish together in a soft flash of pure light, all their mass becoming energy in an instant, the cleanest transformation in nature. Matter and its mirror cannot share the same small space. They trade themselves for a glow and are gone. This is not only theory. Hospitals use it kindly in one kind of scan. A trace of antimatter released inside the body meets ordinary matter and flashes, and the flashes draw a careful map of what lies within, healing guided by annihilation, handled with great care. There is a final mystery here, and it is the reason you exist. The early universe should have made matter and antimatter in equal measure, leaving nothing behind but light, a tiny imbalance. One extra grain of matter in a billion survived. You are built from that faint surplus. Rest in it. Right now, as you lie still, trillions of tiny particles are streaming through your body every second, through the blanket, through your bones, through the whole earth, and leaving not the faintest trace. They are neutrinos, the ghosts of the quantum world. Neutrinos are made in the heart of the sun, in the fusion fire we visited earlier, and they pour out in unimaginable numbers, but they barely speak to matter at all. A neutrino could fly through a wall of solid lead a light year thick, and most likely pass clean out the other side. To catch even a few, physicists build vast detectors deep underground, great tanks of pure water or clear fluid in old mines, watched in perfect darkness for the rare tiny flash of a single neutrino brushing one atom. The reward comes perhaps a handful of times a day, and they shift their nature as they fly, softly changing from one type to another along the way, a subtle quantum blurring that took decades to uncover. Even the ghost, it turns out, lives by the soft, uncertain rules of the small world. There is something restful in such gentle company. The ghosts ask nothing and disturb nothing. They simply pass in their uncountable billions on their way from the sun to the far side of the world. Let them drift through the quiet of the room and through the quiet of you. We call the atom mostly empty, with a dense little nucleus at its heart. But the nucleus too has an inside. Each proton and neutron is built of smaller pieces still, quarks 3 to a bundle among the truly fundamental specks of the world. The quarks are bound by the strongest force in nature, carried by particles charmingly named gluons, for they glue the quarks together, and the binding has a strange manner. The harder you try to pull two quarks apart, the more fiercely the force pulls them back. So a quark is never found alone. Pull hard enough and the energy of pulling simply makes new quarks, which pair off with the old like snapping a magnet and getting two whole magnets, never a lonely pole. The quarks keep their company always. From a small handful of such pieces, a few kinds of quark, the electron and its cousins, the ghostly neutrinos and the particles that carry the forces, the entire material world is assembled. The whole inventory fits on a single page. Nature builds vastness from very few bricks. It is a tidy thought to rest on. Beneath all the world's endless variety lies a short, elegant list of parts, the same everywhere, combining in countless gentle ways. You are an intricate arrangement of a few simple things, and tonight those few things are content to simply be still. Here is a question rarely asked. Why does anything have weight at all? Why is an electron not as weightless as a photon, free to fly forever at the speed of light? The answer, confirmed only in 2012, is one of the deepest in physics. Filling all of space unseen is yet another quantum field, the Higgs field, predicted in the 1960s. Particles moving through it are gently slowed and gathered as a swimmer is held by water, and that holding is what we feel as mass. Weight is a kind of friction with the void itself. For half a century, it was only an idea. Then, in the great ring of the Large Hadron Collider beneath the French and Swiss countryside, physicists slammed protons together hard enough to stir the field, and saw at last its particle, the Higgs boson, flickering for an instant into being. It was the last missing piece of the long inventory of matter, predicted by minds working only with mathematics, found half a century later exactly where they said it would be. Few of our achievements are quieter or grander than that one. So your own weight, settling now into the soft mattress, is a quiet conversation with an invisible field that fills the whole universe. Sinking down is the Higgs field doing its gentle work. Let it hold you the same way it holds everything else that is. The physicist Richard Feynman gave the quantum world its most dreamlike picture of all. To get from here to there, he said, a particle does not take one route. It takes every route at once, every straight line, every wide loop, every absurd detour to the moon and back, all together. Each path carries a little quantum rhythm, and where the rhythms of neighboring paths fall out of step, they cancel. Only near the smooth, sensible, straight-line route do the rhythms agree and add together, and so that is the path we actually see. The madness of all routes sums to the calm of one. It sounds like a poet's fancy, yet it is hard-working physics. Feynman's method describes the behavior of light and electrons to a precision matched nowhere else in science. The particle really does, in some honest sense, Feel out every path before settling on the one. There is a gentle wisdom hidden in it. The smooth, ordinary path you see is not the only one the universe considered. It is the one left standing after all the wilder possibilities quietly canceled away. Calm is what remains when the noise agrees to fall silent. So let your own wandering thoughts be Feynman's paths tonight. Every stray route the mind tries, every detour and loop, gently canceling against its neighbor until only the smoothest, quietest line remains, the soft, straight path down into sleep. There's an old saying that a watched pot never boils. In the quantum world, strangely, it can be made literally true. A quantum system left alone will slowly change from one state to another, but if you measure it often enough, you can freeze it in place, unchanged. Each measurement, remember, forces the system to give a definite answer and resets its quiet drift. Ask quickly enough again and again, and it never gets the chance to wander. It is caught freshly in its starting state every time. Physicists named it the quantum Zeno effect. It has been seen in real atoms held still by the steady gaze of repeated measurement. Attention itself becomes a kind of stillness, not a force pressing down, but a constant gentle asking that leaves no room for change to creep in. But the opposite is the deeper lesson for tonight. Stop watching and the system is free to change at last, to drift, to settle, to become something new. Only when the constant asking stops can the quiet change finally arrive. So tonight, stop watching. Stop checking whether sleep has come. The watched mind, like the watched pot, only holds itself awake. Let your attention loosen and look away, and let the soft change you cannot force arrive at last all on its own. We have seen that light, which seems a wave, can act as tiny grains. In 1924, a young French prince of science, Louis de Broglie, dared to turn the idea around and ask if waves can be grains, might grains also be waves? Might every particle of matter ripple too? It sounded mad, and it was true. Every moving thing he showed has a wavelength of its own, and soon afterwards electrons were seen to ripple and overlap exactly like water waves, spreading and reinforcing in the same gentle patterns. Matter at its root undulates. The faster and heavier a thing, the shorter its wave. A drifting electron has a wavelength wide enough to matter. But a walking cat, a thrown ball, a person, each has a wavelength too, only so unthinkably tiny that it can never ever be noticed. You ripple, you simply cannot tell. And this is the quiet reason the everyday world feels so solid and so sure. It is not that large things have escaped the wave nature of the small. It is only that their waves are far too fine to ever show, hidden a billion times below the reach of any eye. So there is a hidden softness even in the most solid things, in the chair, the floor, the still weight of your own resting body. All of it, very faintly, is wave. Let yourself feel, just for tonight, like something that ripples gently rather than something that merely sits. Remember the entangled pair from earlier, two particles sharing a single fate across any distance. With them, scientists have done something that sounds like pure storytelling, and yet is real and done in laboratories. They have learned to teleport. It is not bodies that travel, nor any solid stuff. What moves is a quantum state. the exact delicate condition of one particle handed across a distance to another, using the shared thread of entanglement as the bridge along which the pattern is carried. And there is a price, a strangely poetic one. To send the state onward, the original must be read, and the reading destroys it. The pattern cannot be in two places at once. It vanishes from here in the very act of appearing there, a perfect handing over, leaving nothing behind. Nor is it truly instant magic. A quiet, ordinary message must follow along, no faster than light, before the far twin can be set right. So nothing outraces the cosmic speed limit. The strangeness is real, but the deep rules of the universe stay gently, firmly intact. Across rooms, across cities, even up to a passing satellite and back, this quiet handing over has now been done. The world is more porous, more connected, more dreamlike than it looks. Let that soft strangeness carry you like a state gently passed from waking into sleep. Let us rest a while among these deeper wonders, mirror particles, passing ghosts, the field that lends us weight, the countless paths that cancel into calm. You need carry none of it. Wonder asks nothing of memory, it only asks to be felt and then let go. Notice how the strangest facts told slowly grow gentle. Antimatter, neutrinos, quarks held by an unbreakable thread, fierce ideas all softened now into a kind of bedtime company. The universe is far stranger than the day allows you to feel, and far kinder too. Let every rote your mind has taken tonight cancel softly against the next, the way Feynman's paths do. The worries, the plans, the half-thoughts, all interfering down to nothing, leaving one smooth, quiet line beneath them all. After a while, we will return to the whispering vacuum and the deep nature of the fields beneath all things, but linger here first among the deeper wonders and stop watching for sleep so that it may quietly come. Two of the gentlest sights in the world hide a quantum secret, the clearness of a window pane and the blue of a daytime sky. Both come from the same quiet rule that the tiny pieces of matter will only accept light that matches their exact inner steps and turn all the rest away. In glass, the electrons have no step that matches visible light. So the light is neither caught nor turned aside, it simply passes through untouched, and the glass seems not to be there at all. The world beyond the window arrives whole, carried by light the glass had no use for. But the high, restless light we call ultraviolet does match a step in glass, and so it is caught and held. That is why you cannot gain a suntan through a closed window. The glass drinks the burning light and lets only the gentle light through. It is a quiet daily quantum kindness. And the sky, the tiny molecules of the air are best at catching and flinging about the shortest, bluest light, scattering it across the whole dome of the heavens until it seems to pour from everywhere at once. The blue of the day is sunlight, scattered and shared by countless specks of air. At evening, when the light must travel the long, slanted way to you, the blue is scattered away before it arrives, and only the warm reds and golds remain. Every sunset you have ever loved is the quantum rules of scattering, painting the air for you. Rest in that soft thought. Look in your mind at a green leaf. Its greenness is not a thing the leaf contains, but a thing it refuses. The leaf drinks in the red light and the blue light to feed itself, and the green light, which it cannot use, it turns away, and that turned away light is all your eye ever sees. Every color around you is this same quiet refusal. A ripe red apple has drunk the blue and green from the light and offers back only red. A golden field has kept the rest and returned the gold. The color of a thing is the light it had no use for, sent gently back to you. And the reason a pigment drinks some colors and not others is purely quantum. Each kind of molecule has its own ladder of inner steps, and it can only swallow the light whose rungs it matches. Color is a fingerprint of the tiny steps hidden inside every substance. The whole painted world, the green of summer, the red of apples, the blue of a jay's wing, is light sorted and returned by countless little quantum ladders, each keeping what it needs and passing the rest along to your waiting eye. There is a soft humility in it. Nothing you see is truly colored. Everything simply wears the light it could not keep. The beauty of the visible world is made entirely of leftovers, and it is lovely beyond measure. Let that gentle thought settle as you drift. For most of history, the atom was a thing you could only imagine, far too small for any eye or lens to reach. Then, in 1981, two scientists built a strange new kind of probe that let us, at last, feel out the bumps of single atoms one by one. Their machine held an unimaginably fine needle a whisper above a surface, so close that electrons could tunnel across the gap in that same quiet passage through walls we met before. The nearer the tip, the stronger the trickle, and so the needle could trace the surface bump by atomic bump. From that faint tunneling trickle, scientists drew the first true portraits of the atomic world, neat rows of round swellings, the actual atoms of a metal, laid out like cobbles on a hidden street. We were no longer imagining them, we were looking. And then a marvel. Using the same needle, they learned to nudge single atoms gently into place, one at a time, and arrange them in tidy patterns, the first time human hands had ever moved the individual bricks of matter where they wished. There is something tender in the thought that the same tunneling which lets the sun shine and powers the smallest switches also lets us so carefully touch the atom itself. The very small is no longer beyond our reach. Rest in how far we have gently come. Every electron, every proton, carries a quiet quantum property we call spin, not really a spinning, but a tiny inner compass, a faint magnetism each particle has simply by being itself. It is one of the deepest and strangest traits of the very small. You are mostly water, and every drop of it is full of hydrogen, each with its own little spinning compass. Lay a body inside a strong magnet, and all those countless compasses quietly turn to point the same way, like reeds leaning together in a steady wind. Then a soft pulse of radio waves tips them, and as they settle back, they sing out a faint answering note, and from those tiny notes, a careful machine draws a picture of the soft, inner landscape of a living body, without a single touch or cut. It is one of the kindest gifts the quantum world has given us, a way to look inside ourselves that harms nothing, built entirely on the faint magnetism of spinning specks too small to ever see. Strangeness turned to gentle healing. So even the quiet compass hidden in every atom of you is useful, is known, is cared for. Your own body is a soft country mapped by quantum spin. Let that thought reassure you as you lie here whole and well and resting. Here is a humble thing the quantum world can do that nothing else can. It can be truly, perfectly random. The ordinary world only pretends a tossed coin, a rolled die, a shuffled deck. All are merely too complicated to follow, but in principle entirely predictable. Even the random numbers inside a computer are only clever recipes, long, tangled sums that look unpredictable but follow a hidden rule and will repeat exactly if you start them the same way. There is no true chance anywhere in the ordinary machinery of the world. But send one lone particle of light at a half-silvered mirror, and it will pass through or bounce back with no cause whatsoever, not hidden, not merely unknown, but genuinely undecided until it happens. This is the one place in nature where chance is real and bottomless. And so we have learned to bottle it. Quiet machines now watch single particles to draw numbers no one could ever guess or repeat. True randomness used to lock away secrets behind doors that no amount of cleverness can pick. There is a strange comfort in a universe that keeps a little genuine unpredictability at its heart, a world not wound up like a clock and left to tick, but open in its smallest moments to something fresh. Let the not knowing be restful rather than anxious tonight. After all these wonders, here is the deepest strangeness of all, and it is a comforting one. The equations of the quantum world work flawlessly. They predict everything we measure to staggering precision, and yet no one fully agrees on what they actually mean. One gentle telling says the cloud of possibility is real and simply settles into one outcome the moment the world takes a look. Another says nothing is ever discarded at all, that every possible outcome quietly happens, the world softly branching into many, each unaware of the rest. And there are other tellings still, each painting a different picture behind the very same flawless mathematics. They cannot so far be told apart by any experiment, for they all predict exactly the same world, the one we see. The difference is only in the story. So the working scientist often simply uses the equations which never fail, and sets the deeper question gently aside. The mystery is not a flaw to be anxious over. It is an open door left honestly ajar at the very bottom of things. There is deep permission in this for tonight. If the wisest minds can hold the greatest mystery lightly and rest and carry on, then so can you. You need not solve anything before you sleep. Let the questions stay open and let yourself close your eyes. We end the deeper strangeness at the darkest place there is, a black hole whose pull is so fierce that not even light can climb back out. For a long time it seemed the perfect darkness, taking everything and giving nothing back at all. But remember the restless vacuum, forever flickering with pairs of particles that wink into being and vanish. Right at the edge of a black hole, the physicist Stephen Hawking saw now and then one of a pair falls in while its twin escapes, and so the whole leaks the very faintest glow. It is the slowest fading imaginable. A black hole sips itself away over spans of time so vast they dwarf the present age of the universe many times over. But fade in the end it will. Even the deepest dark is not quite eternal, and not quite perfectly black. There is a strange tenderness in it, that the quantum restlessness of empty space reaches even into the heart of the void, and lends the darkest thing in all creation the faintest, lingering warmth. Nothing, it seems, is wholly cold or wholly closed. So let the last thought of this deeper strangeness be a gentle one. Even the black holes glow ever so softly with the quiet light of the quantum world. There is warmth in the coldest dark and a faint light at the bottom of everything. Carry that down into sleep. We have reached the very bottom of the small world now. True chance, open mysteries, the soft glow of black holes, and there is nowhere deeper to go tonight. So let us simply rest here at the quiet floor of everything, where there is nothing left to reach for. Notice that the deepest facts of all turned out to be the kindest. Even pure chance is gentle. Even the open questions give permission to rest. Even the darkest hole in space holds a faint and quiet warmth. The bottom of things is not cold, it is soft. You do not need to understand any of it to be held by it. The same rules that light the stars and color the leaves and map the body are holding you, this moment, exactly as you are asking nothing, explaining nothing, simply letting you be. When you are ready, we will rise once more, back toward the whispering vacuum and the larger wonders still to come. But stay here a while first, at the gentle bottom of the world, and let it hold you as you fall at last toward sleep. Take away everything, every atom, every grain of dust, every photon of light, pump a chamber down to perfect vacuum and chill it to the deepest cold. What remains, by every classical account, is nothing. And yet the quantum world finds nothing impossible to arrange. Heisenberg's rule reaches even here. Fields cannot be perfectly zero and perfectly still at once. That would be too much certainty. So the electric and magnetic fields of empty space tremble faintly, forever, a groundless, restless hush that cannot be switched off. Out of that trembling, fleeting pairs of particles borrow energy, flicker into being, and dissolve again, too brief to catch, real enough to matter. Physicists call them virtual particles. Empty space, looked at closely, is a soft, continuous sparkle of almost. This is not poetry pretending to be physics. The trembling vacuum shifts the colors of hydrogen by a measurable whisper. It nudges electrons in ways predicted and confirmed to extraordinary precision. The hum of nothing is among the best measured things in science. So even emptiness in this universe is gently alive. There is no absolute silence, no perfect dark, no true nothing. Always a soft underlying murmur, like a house breathing at night. You have never once been surrounded by nothing. Even the vacuum keeps you company. In 1948, the Dutch physicist Hendrik Casimir predicted something wonderfully odd. Hang two uncharged metal plates a hair's breadth apart in pure vacuum, and they will slowly press toward each other, pushed together by nothing at all. The reason is the trembling vacuum itself. Between the plates, only certain wavelengths of the hum fit, like a narrow room that allows only certain notes. Outside, every note plays. The fuller hum outside presses in harder than the thinner hum within, and the plates drift together. Decades later, the effect was measured delicately and beyond doubt. Nothing, properly arranged, exerts a real force. Engineers who build the tiniest machines must now budget for the push of the vacuum, the way shipwrights budget for the press of the sea. And the vacuum's energy may write the largest story of all. Spread thin across all of space, a faint pressure of emptiness, what astronomers call dark energy, seems to be slowly, calmly stretching the universe wider. the smallest hum conducting the grandest movement. Let the scale of that settle without weighing anything down. The space inside your room hums the same soft hum. Between your hand and the blanket, between any two things, nothing is at work, and it works so quietly that, until tonight, you never heard it mentioned. By now, a deeper picture has been assembling itself silently behind everything we have seen. Modern physics says the world is not built of little balls at all. It is built of fields, vast, smooth, invisible oceans, each filling all of space, one for every kind of particle. There is an electron field everywhere, a photon field everywhere, a field for every quark and neutrino. What we call a particle is a small traveling wave on its ocean, a ripple with a knot of energy at its heart, moving across a sea that never moves itself. Two electrons are identical because they are ripples on the same one sea. A particle vanishing here and appearing there is the sea trading one ripple for another. Creation and annihilation, so dramatic in words, are just the ocean's ordinary arithmetic. You, then, are not an object among objects. You're a long, elaborate, beautifully stable pattern of waves, standing waves on a handful of universal oceans, holding your shape the way a melody holds its tune while the air that carries it changes every moment. It is the oldest lullaby logic there is. You are a wave on a deep, calm, endless sea. The sea was here long before this wave rose, and the sea holds the wave all night. Nothing about you needs holding up separately. The ocean does it whole. Let us rest on that quiet sea a while. No more names, no more dates, just the hum of the fields, the softest sound in existence going on beneath everything like surf heard from far inland. Every breath you take is the sea breathing, oxygen ripples drawn across the membrane of you, energy passed wave to wave, the tide of the blood answering. You have always been more ocean than island. Tonight you can simply float. If thoughts surface, let them be ripples, aloud, brief, widening into smoothness again. The sea does not scold its waves, it just keeps being deep beneath them until they remember how to be sea again. When you're ready, we will ask the loveliest practical question of the night, why anything is solid at all, and why gold glows warm, but the sea will still be hereafter. It always is. Float a little longer first. Here is a puzzle hiding in plain sight. Atoms are almost entirely empty space. We stood in that vast cathedral earlier tonight. Then why does the floor hold? Why does stone refuse your push? What exactly is doing the refusing? The answer was written in 1925 by Wolfgang Pauli, and it is one short commandment. No two electrons may ever share the same quantum state. Each must have its own rung, its own cloud, its own address. There is no doubling up anywhere, ever. That single rule props up the world. Press two objects together and their electron clouds approach the same addresses, which Pauli forbids. The clouds refuse to merge, electrons climb to higher rungs rather than share, and the climb costs energy you feel as resistance. Solidity is etiquette. Without the rule, electrons would all sink to the lowest rung of every atom. Atoms would shrink, chemistry would vanish, and all matter would slump into a dense, featureless soup. No tables, no oceans, no apples. Pauli's etiquette is the architecture of everything. So the bed beneath you holds not because matter is full, but because matter is polite, countless electrons, each keeping to its own place, declining all night to be moved. You are resting on the most dependable courtesy in the universe. With Pauli's rule in hand, the whole of chemistry unfolds like a slow flower. Electrons fill their rungs from the bottom up, one address each, and the pattern of the outermost few decides everything. What an atom loves, avoids, lends, and borrows. Sodium, with one lonely outer electron, gives it away eagerly. Chlorine, one short of a full set, accepts with equal eagerness. The exchange binds them into salt, the taste of the sea born from two atoms completing each other's arithmetic. Carbon, with four open places, would rather share than give or take, four steady handshakes at once. From that gentle generosity come chains, rings, lattices, diamond and graphite, sugar and oil, leaf and bone, and every molecule of every living thing. Water owes its life-giving strangeness to the same rules. Its molecules lean toward one another in soft quantum handholds, which is why water climbs the veins of trees, why ice floats and lakes freeze from the top down, sheltering the sleeping fish below. Every flavor, scent, color, and cure is electron arithmetic, quantum rungs courteously filled, the chamomile in evening tea, the lavender on a pillow, the melatonin rising in your blood right now, all of it chemistry, all of chemistry, quantum. Most metals are silver, polished iron, aluminium, platinum, all the same cool gleam. Gold alone glows warm. People have loved that color for 10,000 years, and the reason for it, of all things, is quantum physics traveling near the speed of light. Gold's nucleus is heavy, its pull fierce, and its innermost electrons race around it at a substantial fraction of light speed. At such speeds, the rules of relativity squeeze their orbits tighter, which shifts the rungs of gold's staircase and shifts the colors it swallows. Where silver reflects all colors evenly, gold's shifted staircase drinks in the blue and gives back the rest, and white light minus blue is that deep, famous warmth. The crowns of kings owe their glow to electrons running a little too fast for ordinary rules. The same racing electrons explain stranger things. Why Mercury, gold's neighbor, cannot hold itself together as a solid and pools as a liquid mirror at room temperature, the only metal that flows before it is ever heated. So even luxury is physics, and even physics has its luxuries. Wherever something gleams warm in the lamplight tonight, a ring, a clasp, a picture frame, this small realm is quietly showing off. Admire it once more and let your eyes fall closed. A magnet on a cold morning holds a note to the refrigerator door with a force that never tires, never feeds, never sleeps. We hand magnets to children as toys, yet their steady pull is one of the most purely quantum things in any home. Each electron carries a tiny built-in magnetism called spin, not from any spinning, but woven into what an electron is, like its charge. Every electron in the universe is an identical little compass needle, the smallest there could ever be. In most materials, the needles point every which way and cancel. But in iron, the quantum rules, Pauli's etiquette again, working through the arithmetic of energy, reward neighboring spins for aligning. Whole regions agree, then the regions agree with each other, and the metal becomes a magnet. Earth itself does something kindred. Slow currents of molten iron far beneath your bed sustain the great gentle field that swings every compass and shields the night sky's auroras into being. You sleep inside a magnet the size of a world, and nothing about any of it ever switches off. The spins hold their agreement through the night, the core keeps its slow currents, the field stands its watch. The universe is full of forces that hold without holding on, a fine thing to imitate as you let go. Let us rest on these polite foundations a moment. Electrons keeping to their own addresses, atoms completing each other's arithmetic, spins agreeing in their billions without a word. The solidity of the world turns out to be a kind of courtesy. Everything beneath you is keeping its agreements tonight. The floorboard's carbon is sharing its 4 steady handshakes. The iron in the bed frame is aligned and easy. The water in the glass holds hands with itself in the dark. The household of matter is in order. There is nothing you must hold together. That was never your job. The etiquette of electrons has kept every floor that ever held a sleeping child, and it does not lapse at night or ever put the weight down. The courtesy will carry it. When you are ready, we will travel to the coldest places ever made, colder than space, where the quantum world steps out into plain sight and matter, learns to levitate. But rest first, here on the warm side of absolute zero, where it is comfortable. In 1911, in a laboratory in the Dutch city of Leiden, Heike Kamerling Onwes was master of the coldest place on Earth. He had learned to turn helium itself to liquid, a few degrees above absolute zero, and in that unearthly chill he began testing how metals behave. He cooled a thread of mercury, expecting its electrical resistance to shrink politely as the heat jostling of its atoms calmed. Instead, near 4 degrees above absolute zero, the resistance did not shrink. It vanished, utterly, instantly, completely. Not low resistance, none. A current started in a ring of such metal flows on by itself, round and round, without any push, essentially forever. Experiments have watched such currents circle for years without fading a measurable whisper. Onwes called it superconductivity. It took physicists nearly half a century to understand why. In the deep cold, electrons, lifelong loners by Pauli's rule, form delicate pairs, and the pairs merge into a single vast quantum wave filling the whole metal. One wave cannot stumble on impurities, it simply flows around them whole. Hold that image of frictionless flow as your shoulders loosen, movement without loss, current without effort. Down in the cold country, the quantum world shows what it can do when nothing disturbs it. Sleep is your own version of that stillness. Superconductors keep a second marvel in reserve. In 1933, Walther Meissner found that on crossing into the superconducting state, a metal abruptly expels all magnetic fields from its interior, sweeps them out like a tide pushed from a bay. Bring a magnet near, and the superconductor builds perfect mirror currents that push the field away. The result looks like quiet sorcery. The magnet rises and floats, steady as a held breath, resting on an invisible cushion that never tires and never spills. It is not a trick of balance. Nudge the floating magnet and it sways, then settles back. Flip it and it floats on undisturbed. The superconductor grips the field lines themselves, holding the magnet in a quantum cradle, no ordinary material can weave. Scaled up, the cradle carries people. In Japan and China, magnetically levitated trains rest on exactly this physics, hundreds of tons of steel and passengers floating a hand's width above the guideway, gliding in near silence at the speed of small aircraft. Floating, frictionless, silent, the cold country keeps offering pictures of effortlessness, and you may borrow every one of them. Let the mattress be your guideway. Let the night carry the weight. Nothing about rest requires friction. Cool helium further still, below about 2 degrees absolute, and in 1937 physicists found it crossing into something stranger than any solid, a superfluid, a liquid with no internal friction whatsoever, the whole of it one single quantum state. Superfluid helium does things no ordinary liquid can dream of. Set it swirling and the swirl never slows. Pour it through channels too fine for any liquid to pass, and it flows as if the walls were rumors. It cannot be stirred into reluctance. It has none. Strangest of all, it climbs, left in an open vessel. A film of superfluid creeps up the inner wall, over the rim, and down the outside, the container slowly emptying itself drop by drop from below. Gravity is not defeated, just quietly outmaneuvered. None of this is sleight of hand. At that temperature, a large share of the helium atoms settle into one identical lowest state. Billions of atoms behaving as a single thing, a quantum chorus singing one note. What one atom may do, the whole liquid does together. The cold country, it turns out, is not barren but graceful. The quantum world's ballroom where matter moves without resistance the moment the noise of heat falls away. Quiet your own noise, breath by breath, and feel how much easier everything glides. In 1995, in a laboratory in Colorado, physicists chilled a tiny cloud of atoms further than anything had ever been chilled, to a few billionths of a degree above absolute zero, colder by far than the space between the galaxies. At that unimaginable cold, the atom's waves of possibility spread wider and wider until they overlapped, and then, as Einstein and the Indian physicist Bose had predicted 70 years earlier, thousands of atoms collapsed into one shared state, a Bose-Einstein condensate. A condensate is matter behaving as one giant quantum wave, a single superatom big enough in principle to photograph. The fuzzy rules of the smallest world, walked up the staircase of cold until they stand at human scale, visible and slow. Light itself can be tamed inside such clouds. Researchers have slowed beams of light from 300,000 kilometers a second to the pace of a bicycle, and for moments even brought light to a complete held stop, a sunbeam parked. Matter as one wave, light standing still. The deeper the cold, the more openly the universe shows its quantum heart, and the lesson for 2 a.m. is gentle. Stillness is not emptiness. Stillness is where the subtlest things finally become visible. Absolute zero, the temperature at which all heat motion would cease, sits at minus 273 degrees and a fraction. Laboratories have crept within billionths of a degree of it, but the final step can never be taken, and the reason is quantum to its core. Perfect zero would mean perfect stillness, and perfect stillness Every atom's position and motion both exactly fixed is precisely what Heisenberg's rule forbids. So even at the bottom of cold, the zero-point tremble remains, matter's softest heartbeat, which nothing can silence. Helium wears that truth openly. At ordinary pressure, it never freezes, no matter how cold. Its zero-point tremble alone is enough to keep it liquid at absolute zero itself, a substance that cannot stop dancing even at the end of all warmth. There is a quiet comfort in a universe with no absolute stop. Total stillness, total silence, total dark, none of them quite exist. Beneath every rest there remains a faint warm tremble of being, the smallest possible yet. So do not aim for perfect stillness tonight. Nothing in nature achieves it, and nothing needs to. Your breath will keep its soft tide, your heart its low drum, your atoms their gentle tremble. That is not restlessness. That is what being made of quantum things feels like at rest. The cold country is not only beautiful, it works for a living. Hospitals could not see inside the body as they do without it. The great imaging machines wrap their magnets in superconducting wire, bathed in liquid helium, currents circling without loss day and night. Particle accelerators steer their beams with thousands of superconducting magnets. Radio telescopes chill their receivers until the faint whisper of distant galaxies stands clear of the electronic's own murmur. To hear the universe, we first quiet the instrument. The deepest cold of all serves the newest machines, quantum computers, whose delicate states survive only a hair above absolute zero. Their gold-plated housings, tier upon gleaming tier, are among the coldest objects in the known universe, colder than anywhere nature ever made. There is a fine irony here. We chill these machines into near-perfect silence, so that within them the liveliest quantum possibilities can unfold undisturbed. Quiet on the outside, rich activity within, which is of course a fair description of sleep. So the cold country earns its keep, and we will meet its golden chandeliers again before morning. For now, draw the blanket a little closer. You are the warm country, and your own quiet work of dreams also runs best undisturbed. Let us rest here, warm above the cold country. Somewhere tonight, helium is climbing its glass walls, magnets are floating in the dark, and currents are circling their rings without loss, all of it silent, all of it steady, none of it needing you. You are perhaps 37 degrees of gentle warmth, a small steady star of body heat in the night. Between you and absolute zero lie 300 degrees of distance. Between you and anything cold tonight, a good blanket and a sound roof. You are well placed. Let the images of the cold country do their slow work. The floating stone, the climbing liquid, the one wave made of many. Effortlessness exists. Nature does it nightly. You are doing it now, one unhurried breath at a time. When you're ready, we will come back indoors to the lamps and screens and quiet machines of an ordinary evening and find the quantum world working in every one of them. But warm yourself here first as long as you like. In December 1947, at Bell Telephone Laboratories in New Jersey, 3 physicists coaxed a small crystal of germanium into doing something no crystal had done before. It took in a weak electrical whisper and gave back the same whisper, amplified. The transistor was born. It looked like nothing, a sliver of gray crystal, 2 hair-fine contacts, a clumsy spring. But it could switch and amplify current with no moving parts, no glowing filament, no warm-up, just electrons steered through a solid by pure quantum rules. The steering works because crystals offer electrons broad avenues of allowed energy and forbidden gaps between staircase physics scaled up to a whole solid. Lace the crystal with chosen impurities, and you decide where electrons may flow. Matter becomes programmable. Then came the shrinking, the most relentless craft story of the modern age. Transistors by the dozen on a chip, then thousands, then millions, and now many billions on a sliver smaller than a postage stamp, each switching billions of times each second, faithfully for years. Every message you have ever sent, every photograph and song and saved memory, has lived its life as quantum traffic in such crystals. The phone resting dark beside you holds more transistors than there are stars in our galaxy, silent now, like everything else in the room. In 1960, the engineer Theodore Maiman took a rod of synthetic ruby, wrapped it in a flash lamp, and drew from it a light no one had ever seen, a thin, pure, deep red beam in which every wave marched perfectly in step. The first laser. Ordinary light is a crowd leaving a theater, every photon its own direction, color, and timing. Laser light is a procession, one color, one direction, every crest aligned with every other. The difference is quantum choreography. Einstein had supplied the key in 1917. An excited atom brushed by a passing photon of just the right color can be persuaded to release its own photon as a perfect copy, same color, same direction, same step. Light begets identical light, and the procession swells. Today, those processions are everywhere, mostly unnoticed. They read the groove of every disk, carry the world's conversations as flickers down ocean floor glass, measure the slow breathing of bridges and volcanoes, and mend with exquisite care the retinas of human eyes. And one procession runs to the moon. Mirrors left on the lunar dust half a century ago still catch laser pulses from Earth and send them home, timing the moon's slow retreat to the width of a fingernail each year, quantum light measuring the heavens while you drowse beneath them. Look around any evening room and the quantum world looks back. The amber of the reading lamp, the warm white of the ceiling light, the soft glow of a bedside clock. Nearly all of it now comes from light-emitting diodes, which are quantum staircases cast in crystal. Inside an LED, electrons cross a deliberate little cliff built into the crystal, and each one falling releases exactly one photon whose color matches the height of the fall. Engineers tune the cliff, atom by atom, and choose the color of the light. Blue was the stubborn one. For 30 years, no crystal would yield it brightly. When researchers in Japan finally tamed it in the 1990s, white LED light became possible, and the world's lighting began to change. The work earned a Nobel Prize, and it dims your ceiling tonight. Screens carry the craft further. The newest displays paint their colors with quantum dots, crystals so small that their size alone sets their color. A few thousand atoms glowing green, a few thousand fewer glowing red. Geometry, doing the work of pigment. All this light is falling electron light, billions of tiny quantum descents per second, each one a small letting go. The evening world glows because electrons everywhere are stepping down to rest. Dim the lamp when you are ready, they will manage the dark. The steadiest timekeepers ever made hold no pendulum and no spring. They keep time by the atom, by the perfectly fixed color of light that cesium atoms absorb and release, a rhythm written into the staircase of the element itself, identical in every cesium atom that has ever existed. Since 1967, the second itself has been defined this way: the time it takes that cesium light to swing just over 9 billion times, not the turning Earth, not any machine. An atom's quantum song is the world's official heartbeat. The best of these clocks would wander by less than a second over the age of the universe. They are sensitive enough to show time itself running faster on a mountain than in a valley. Einstein's curved time read plainly off a quantum dial. And those clocks find you nightly. Navigation satellites each carry atomic clocks, and every map, pin, and turn-by-turn direction is a triangulation of their quantum ticks, corrected faithfully for the strange truths of relativity. Finding your way home is applied quantum mechanics. Your own evening runs on gentler clocks, the slow cesium of habit, the body's deep circadian swing, but it is good to know the night is well timed, down to its smallest parts. The atoms are counting beautifully. You may lose count now. And so to the golden chandeliers. A quantum computer does not store crisp zeros and ones. Its working pieces, qubits, are quantum states, able to hold 0 and 1 in superposition, and to entangle with one another into possibilities no ordinary memory could list. Where an ordinary computer tries paths one after another, a quantum computer can let many paths interfere, crest meeting trough, wrong answers canceling like ripples, right ones brightening the two-door experiment, recruited into arithmetic. The catch is fragility. A qubit holds its blur of possibility only while nothing disturbs it. No stray heat, no wandering photon, no tremor, hence the chandeliers, tier below tier of shielding and cold, descending toward a chip held colder than deep space, where the world's noise finally falls silent. These machines are young, clever at a few rare tasks, toddlers at most others, but their promise runs deep, designing molecules by speaking nature's own quantum language instead of translating everything expensively into classical approximation. Medicine, materials, fertilizer, batteries, all are quantum problems at heart. Whatever they become, their deepest requirement will not change. Profound quiet, profound cold, disturbance kept far away. The most advanced machines we have ever attempted work only in conditions resembling deep sleep. Take the hint and keep them company. The quantum world has one more profession. It listens better than anything else can because quantum states are so easily disturbed. They make matchless sensors, instruments that tremble meaningfully at the faintest whisper of the world. Clouds of cold atoms, dropped a few centimeters inside a vacuum, feel the pull of gravity so precisely they can map what lies beneath a street, old tunnels, buried rivers, hidden voids, without turning a single spadeful of earth. Diamond, of all things, listens too. A particular flaw in its lattice, one nitrogen atom beside one missing carbon, glows in response to magnetic fields so faint they come from single living cells. Physicians hope such diamonds will one day listen to the quiet electricity of thought itself. And the grandest listeners of all wait in long vacuum corridors, Gravitational wave observatories whose laser arms feel space itself stretch by less than a thousandth of a proton's width when black holes collide far away. At that delicacy, even the vacuum's quantum hiss must be soothed, and it is. Instruments that hear stars merge and cells whisper, built from the world's shyest states, sensitivity, it turns out, is a strength when it is sheltered well. Yours is too. Let the room shelter it now. There is nothing more tonight that needs listening for. Let us rest among the quiet machines. All over the sleeping world they are at it. Transistors switching, lasers humming down seabed glass, atomic clocks counting their 9 billion beats, golden chandeliers keeping their cold vigil. None of it asks anything of you. Your own room is a small museum of the quantum century. The chip in the phone, the diode in the charger light, the clock keeping satellite time, all of it built from staircases and clouds and tunneling, and all of it right now perfectly content without your supervision. Somewhere, a navigation satellite is crossing the stars above your roof, its atomic heart ticking, correcting for curved time, asking for no thanks. The infrastructure of the night is deeply competent. You can be off duty. When you're ready, we will step outside the workshop entirely into feathers and leaves and your own warm body and find the quantum world alive in living things, but idle here first among the well-made machines, as long as you like. Each autumn, small songbirds cross whole continents by night, holding a true course through the dark. The European robin is among them, and the way it finds its bearing may be one of the most delicate quantum tricks in all of nature. Scientists believe the secret lies in the bird's eye. When dim light strikes a special protein there, it creates a fleeting pair of particles whose quantum states are entangled, and the angle of the Earth's magnetic field nudges that pair ever so slightly one way or another. If the idea is right, and researchers are still carefully testing it, the robin does not feel the magnetic field as a force, but sees it as a faint pattern of light and shadow laid across its view of the sky, brightening or dimming as it turns its head. What astonishes physicists is the delicacy. In their coldest laboratories, entangled states survive disturbance for the briefest flickers. Yet in the warm, wet, jostling tissue of a living eye, nature seems to hold such a state just long enough to read a direction from it. However, the full story turns out. The image is lovely to carry into sleep. A small bird steering by entangled light, reading the planet's quiet field as a glow in its eye, flying sure through the dark while the world below it sleeps. Fly well, little one. Every green leaf performs a feat our finest engineers still envy. It catches a photon of sunlight and must carry that grain of energy to a tiny reaction center where it can be stored, and it does so with an efficiency close to perfect, wasting almost nothing on the journey. The puzzle is how the energy must thread a maze of molecules to reach its destination, and a blind stumble down random corridors would lose far more along the way. Somehow the leaf finds an almost ideal route, nearly every time. For a while, some scientists suspected a quantum shortcut, that the energy spreads as a wave exploring many paths at once like light through the two doors, and so feels out the best route before committing. The idea stirred great excitement and great debate. Today, researchers are more cautious. The warm, busy interior of a leaf likely blurs any long quantum march more quickly than first hoped, and much of the efficiency may have simpler roots. Nature keeps her methods close, and honest science waits for better evidence. Either way, the wonder stands undimmed. Every calorie in every meal you have ever eaten began as a photon caught by a leaf and shepherded, with exquisite care, through a molecular maze. You are quite literally running on gathered sunlight. Rest well on it. Your own eyes are quantum instruments of extraordinary sensitivity. Deep in the dark adapted retina, the slender rod cells can respond to a single photon, one solitary grain of light, the smallest parcel that exists, enough to stir a living cell to signal. Careful experiments have confirmed it. Under the best conditions, a human being can register a mere handful of photons, and a rod responds to just one. There is no more sensitive a light detector imaginable, for one photon is the least there can be. Evolution reached the floor of physics. Your brain wisely hushes most of these whispers. A single photon could otherwise set the dark aflicker with false sparks. Only when several arrive close together does it let you truly see quantum sensitivity paired with quantum restraint. This is why a long quiet while in darkness lets you see stars invisible at first. The rods are slowly winding up to their single photon best, reaching down toward the very grain of light. Your eyes become, in the dark, the most sensitive thing you own. So as your eyes close now, they close at the very edge of physics, instruments tuned to the smallest light there is, switching gently off for the night. There is nothing left out there faint enough to need them. Let them rest at the floor of the world. Go down into any living cell, and you find quantum machinery running the business of being alive. The enzymes that build and break the molecules of life routinely move protons and electrons by tunneling, the same wall walking that lights the sun, now powering a heartbeat. In the membranes of your cells, electrons hop along chains of molecules, tunneling from one stepping stone to the next, ferrying the energy that ultimately lifts your chest with each breath. Respiration itself leans on the gentle impossibility of tunneling. Even the slow drift of life's changes may carry a quantum whisper. A proton sitting in the rungs of the genetic code can, on rare occasion, tunnel to a neighboring position, a tiny quantum slip that some scientists think contributes gently to the variations evolution works upon. This young field has a careful name, quantum biology, and its honest researchers are quick to separate the firm from the hoped for. But the direction is clear and humbling. The line between quantum physics and living warmth is far thinner than anyone once supposed. So the strange small world is not a distant curiosity behind laboratory glass. It is breathing in you right now, tunneling protons, hopping electrons, the quiet quantum engine that has kept you alive through every night of your life and is running smoothly still. One honest question has been waiting politely all night. If the small world is such a blur of clouds and both at once, why does the large world look so crisp and sure? Why is a teacup simply a teacup here and not there, never humming with possibility? The answer is a quiet process called decoherence. A quantum thing keeps its blur only while it is left perfectly alone. But nothing large is ever left alone. A teacup is struck by trillions of photons and air molecules every instant, each one a tiny measurement, asking it again and again to choose. Under that endless, soft questioning, possibilities lose their grip almost instantly. The blur does not break so much as leak away into the surroundings. Far too fast to see, the cup settles into being simply, definitely, reliably here. The world decoheres into solidity. So the strangeness was never lost, only hidden by abundance. The quantum blur is still there beneath every solid thing, washed smooth by the constant touch of the world, the way 1,000 voices blend into a single steady murmur you can sleep through. There is deep comfort in decoherence. It is why the morning will be solid and dependable, why the floor will hold and the cup will pour. The wild small world builds, out of its own ceaseless touching, a calm and trustworthy large one for you to wake into. Lift your gaze at the end to the largest things there are and find the smallest world written across them. The galaxies are not scattered evenly through space. They gather in great threads and sheets with vast dark voids between, a cosmic web spanning all that exists. That web grew from seeds, and the seeds were quantum, in the universe's first sliver of an instant. The same restless trembling that fills the vacuum tonight rippled through the infant cosmos, tiny patches a shade denser, a shade thinner, pure quantum chance. Then the universe expanded, fast and vast, and stretched those microscopic flickers to astronomical size. Where chance had left a little more matter, gravity gathered more still, and over billions of years those quantum whispers grew into galaxies, stars, planets, and the ground beneath you. It is the most sweeping thought of the night, and a gentle one. Every star you can see, every galaxy beyond them, and the very atoms of your body trace their arrangement to a few quantum quivers in the first moment of time, the small world casting the largest shadow there is. So the quantum world is not only beneath you, it is above you and around you and behind the whole story of everything, from the trembling vacuum to the web of galaxies. One quiet strangeness runs through it all, and tonight you are resting in the middle of it, perfectly at home. Let us rest now in the middle of everything, for that is exactly where you lie. Far below you the quantum world hums in every atom. Far above you it is written across the galaxies. You are poised in the gentle middle, made of the small gazing at the large. You need carry none of tonight's wonders into tomorrow, not the doors, not the clouds, not the threads of entangled light. They will go on without your remembering, exactly as they have always done. The lesson was only ever this: rest is woven into the deepest law there is. Let the small world do what it does best, beneath your stillness, atoms holding their shape, electrons keeping their courteous places, the vacuum humming its faint warm yes. You are held together by laws that never tire and never lapse. You may let go completely. There is nothing left to do tonight, and all the smallest things in the universe are doing it for you. Breathe slow, sink soft. Let the quiet strangeness beneath everything carry you the rest of the way down into sleep. Our journey through the quantum world is over, and you have done the one thing it asked. You have rested. There is nothing to keep, no fact to hold, no answer to carry into the light. The whole strange, beautiful tour was only ever a soft place to lie down and let go. If you're still awake, there is no fault in it. Stay here in the quiet hum of the small world a while longer, breathing slow, warm, and safe and held. Sleep arrives the way a quantum answer does, not when forced, but when the world grows still enough to allow it. And if you're drifting now at the soft edge of sleep, then let go completely. The atoms will hold their shape, the vacuum will keep its gentle hum. The sun is tunneling toward another morning, and every law of the small world will keep faith with you through the dark. Thank you for spending this night with us here at the Circadian Institute, resting in the quiet strangeness beneath all things. Sleep now, and sleep well. The whole vast universe is humming softly around you, and you are perfectly at home in it. Good night, and the deepest of good rests to you.